So you should have an image that looks like this. So we're going to color this together and learn about the different portions of lung capacity that allow us to have, total volume within our lungs when we're breathing in and out. So you're going to need different colors to kind of color this together. I would say you'll probably need, let's see, one, two, three, four, five, probably five colors. So the first thing we're going to start with is we're going to start with um, what is our tidal volume. I'm going to pick this color for tidal volume. So tidal volume is going to be the volume in our normal breath. So that's when we're just sitting here breathing normally. So that portion of our graph that is the tidal volume is going to be this region right here. So I want you to color this region as the tidal volume. So the part of the graph that actually is the tidal volume waves are going to be like this portion here and this portion here. So as you can see, they kind of look like normal breaths, in and out, in and out. Okay. And so then when we breathe in and out normally, there's going to be some extra room in our lungs. Obviously, we have to be able to breathe in a lot more than that, and we have to be able to breathe out a lot more than that. So we're going to look at then next, we're going to look at the inspiratory reserve volume. So when you're breathing in normal, there's additional volume of breath that can be inhaled after that normal inspiration, and that's going to be your inspiratory reserve volume. So that's going to be this upper portion of this. So you want to pick a color and color per chunk. And so your inspiratory reserve volume is basically going to be this portion of the graph here. And so it's going to extend from the top of your tidal volume peak all the way up to the top here of the tallest peak. And that's called the inspiratory reserve volume. Then, obviously, we breathe out the opposite direction too, which is called our expiratory reserve volume. And so, our expiratory reserve volume is going to be the volume expired after normal breath. So, if you like breathe out normal and then push out everything out of your lungs that you can, that extra that you do is going to be your expiratory reserve. So, that's going to be this portion of the graph right here. And so, then and you're going to color this portion here as your expiratory reserve volume. And then that value would be from the bottom of the tidal volume peak all the way down to the bottom of this peak. And we're going to analyze graphs like this tomorrow when I do my demonstration of spirometry. And then we have a portion of our lung capacity that we don't really access much, but we still have it there. And that's called our residual volume. And that's going to be this portion down here at the bottom that is basically just like left over in our lungs um, that we have after maximum expiration. So it's basically just like the leftover region at the after we've expired as much as we possibly can. And then the there's a couple other values that you can look at that are important when analyzing. So the first one is vital capacity. So vital capacity is the total volume of air that can be exhaled after maximum inhalation. Okay, so your vital capacity is going to be, it's going to have this equation here. So vital capacity equals the tidal volume plus the inspiratory reserve volume plus the expiratory reserve volume. So basically it's these here. And so essentially the only thing that's not included is the residual volume. So that is all of the air that if you like breathe in as deep as you can and you breathe out as deep as much as you can, that's going to be your vital capacity. And so a lot of times that's like those peak flow values that we looked at with Melissa. A lot of times that's what they're kind of evaluating the health of. And then your tidal capacity then for this very last one at the bottom. The tidal capacity is going to be looking at the sum of the vital capacity and the residual volume. So as the name implies, it's like your total lung capacity. So it's this whole thing. So this is all of the air you can breathe in, all the you can breathe out, and everything that's left over in your lungs that you don't actually um, access very much on a regular basis. So whatever color you chose for total lung capacity, I want you to color, and then we're going to note that the total lung capacity is typically approximately 5,800 milliliters, and this is total lung capacity. Okay, and then I would like you to kind of know on the right side of the lung, then we're going to divide it up into the different sections of our colored graph. So my blue section, I'm going to have be here, and then pink section will be about here, green. Do the same thing on your graph, try to make it like approximate. And then we're going to write the values of how much of our total lung capacity each of these are, okay? So for our residual volume is typically approximately 1,200 milliliters of our total lung capacity. And then our expiratory reserve volume is approximately 1,100 milliliters. And our tidal volume is typically 500 milliliters, so this one is definitely the smallest because you're just breathing out and in normally. And then our inspiratory reserve volume is 3,000 milliliters, and that kind of makes sense, right? Is that you should be able to have a lot of room left in to breathe in a lot more because of exercising and just the ability for your lungs to be able to grow and expand over time. Okay, so that's kind of that's lung capacity. Um, and so just make sure that you have labeled this and um, understand this because this will be important for tomorrow when we actually do the spirometry lab.